Welcome back to the Blazor Server In-Depth course. In this lesson, we're going to be looking at swapping out the data access layer, or the data access section. So remember I talked about the fact that, yes, we're going to use Microsoft SQL for this course, but that doesn't mean that you're stuck with SQL or that what you're learning isn't relevant for pretty much any other data access out there. So in this lesson, we're going to look at what that would look like to change out our data access layer. Okay? So let's go to Visual Studio and let's open up. First of all, we're not going to deal right now, the implementation is person SQL data service, but it's just an interface. So if you create a different interface, let's just create one real quick. We're not going to actually do the work here. We're going to create a dummy one. So new class, we're going to call this dummy data service. Dummy person dummy data service. How about that? There you go. Now it matches the convention. We'll make this public. And we're going to say implements person data service. Control dot implement that. Now we have the implementation. Okay, so what we're going to do is we're going to create a private list of person model called people equals new list of person model. All right, so that's a private value. So people.add person. That's our create. Our delete, which, by the way, this is a task. So what we need to do is we will this Control X, and we'll say return task.run. And in here, we'll pass in our code, which this is just basically wrapping what's a simple code, but it runs it in a task, so we can return that task and get asynchronous. So for our delete, okay, what we're going to do is we're going to say people.remove, and we're going to do the same thing, people.where, control dot to add using system.link, where x arrow function x.id equals id, first or default, and we're going to remove that person from a list. Okay, read. Actually, not even this. We're going to say task.fromResult, and then we'll say people. Okay, what that's going to do is going to return this list of people, and then this read people from ID will do the same thing, only we'll say result people dot where x dot id equals id, first or default. Okay, guess what? Oh, I have one more. I have an update. All right, so we'll do something similar to this, and we'll paste it in here. and we'll say people. Actually, let's make this into multiple lines here so we can actually see what we're doing. We're going to say var p equals people.where x.id equals person.id, first default. If p is not equal to null, then p.firstname equals person.firstname, p.lastname equals person.lastname, and p.date of birth equals person.date of birth. Okay, so that's all our update's going to be. So I just created an in-memory data access. Now, that's all I did in the class library. To update my Blazor else entirely, and I'm able to create, read, update, and delete. At least once I figure out this whole ID issue. Okay? So that's gonna bug me. I really hate things that are undone. So let's fix that. So whenever we create a person, we're going to take us in 2 steps instead of just 1. So we're gonna say int I equals people. Let's just do people.count. Nope, that's not going to work. Let's do this. People.order by descending x.id. So the largest one is at the top and it goes down by there. And then we're going to say first or default. Okay. I'm gonna grab this and put in a different variable. So var top equals, and that's gonna be the top person, the largest ID, if there is one. So then we're gonna have an int I equals 1. That's the starter value. And if top is not equal to null, and I know I can put this in 1 line. I prefer not to. I'm going to say I equals top.id plus 1. So what that's going to do is if we have no people in the list at all, then our order by descending isn't going to work, and first default is going to return null. Therefore, what we'll do is we'll have null here, and we'll say if it's null, then I is going to be 1 because that's the default value for I. But if top is not null, meaning let's say we have 1, 2, and 3, we'll return 3 here. Then 3 plus 1 is 4. That's the new value. And that almost works. In fact, I love this so much I hate to delete it, but I'm going to delete it. And the reason why is because you have to think through as a developer, what are the implications of this? And the implications of this are it's going to work great until you start messing with it. And so if we create 5 records, let's see, ID number 1, 2, 3, 4, and 5, nice and neat. And then we delete the last record. What's the new ID going to be for the 6th entry? ID number 5, which we already had, because the top number is now 4, which we don't ever want to repeat ID numbers. Now, it doesn't matter in this scenario, but just to be complete, I think what I'm going to do, since it's in memory, I'm going to say private int current ID. And actually, I'm going to start that at 0. And here's what I'm going to do. It's almost too simple. I'm going to say current ID plus equal 1 before I then say person.id equals current ID. And then I add person to the list. That way, I always increment by 1, so it always gets a new value that's higher than the last value, and it starts at 1. Simple. Let's run it again, make sure it works. I know it's a little bit of a rabbit trail, but I do think that you need to think through these scenarios. Even if they're practice, it's really good for you. So, Tim, Corey, I'm not going to worry about dates here, so I'm just going to grab this, Sue, Storm, create people. There we go. Now we have 2. I can delete 1 and delete it. I can delete the other and delete it. And now, just to show you, something like that, and create person, it's ID number 3, even though there were no records in the in-memory database. So there we go. We can update like so. We can delete like so. So now we have a full in-memory database that gets wiped out every time we close the application or refresh the application or open a different browser because of the fact that we're currently adding as add scoped. So it's not really helpful from a use perspective, from the client's perspective, but it's actually great for testing. This actually acts like a SQL database, but it restarts every single time. That's pretty cool. This also indicates just how you would mock this out if you were trying to do unit testing and didn't want to actually write to a database. So even though we did all this work that was all SQL focused, in just a few minutes, we replaced all of that with a different database, an in-memory database, but still, we replaced all that with a different database, and now we have our application still running just in that new in-memory database instead of with SQL. Okay? So that's what I mean when I say that, hey, this is not about SQL. You can replace this with pretty much anything you want. Now, the one thing I'll point out is that if you want to replace what you have right now with a NoSQL solution, you will have a little bit more of a problem, because NoSQL and SQL are pretty different. Even though it feels like they're similar, they are very different. And so NoSQL, the IDs are GUIDs, and they're BSON usually, and there's a lot of differences. And so when you're building your solution, you probably should know, are we going the SQL route or the NoSQL route? Because if we were going to go NoSQL right now, or change over to that, we'd have to change quite a bit about how our application works. Because we base everything off of these IDs, including up through the Razor pages in Blazor. So we can't just swap this out for a NoSQL solution. So we do have to know up front, or pretty close to up front, whether we're using SQL or NoSQL. But once you know that, if you follow the same pattern where you create an interface and then have your implementation, it won't matter if it's MongoDB or Cosmos DB or the list goes on, CouchDB, PouchDB. They'll all work because you have that interface and you have a similar data set you're working with for each of them. So just that's a note to be thinking about before you build your application. Okay? But follow the same pattern and you'll have this disconnected architecture. Now, just to kind of bring it on home, I talked about at the very beginning that your data access should be separated from your user interface. And your user interface shouldn't care how it gets the data. It should just care that it needs data and it asks for it. That's what we're doing here. We don't care how we get the data. We're just saying, hey, I need data. And so I ask for it, and then because I ask for it, you figure out how to get it. So in this case, it's in memory. In this case, it's talking to SQL. If you notice, this one even uses connection strings, and this one doesn't care. There's no connection strings to use. So what this is doing is totally separating your user interface from your business logic and data access. That's all done in these files, and it's all behind this one interface, which you can swap out the implementation of depending on what you need. Okay, that's it. So practice what you've learned, and then keep working on your homework, tackle that, and try and get it all done, because next up is the section review or section conclusion, where we'll look over what we've talked about and then also go over our homework. So try and get your homework done first so that you can just compare what you did to what I did instead of just watching. Okay? Learn by doing.